Now we're going to talk about resistance. And we talked about this before, but know that when it comes to this particular procedure, um, we are talking about our geometrical representation for resistance. And it is based on the cylinder that we have here. It doesn't have to just be a cylinder, but it is based on a cylinder. Well, the cylinder that we have here could be any material, but resistance is measured in ohms. So geometrically, it's going to be R is equal to resistivity times L over the cross-sectional area, A. A is typically our American wire gauge. L is the length of the device, and rho is the material, copper, aluminum, some insulator, just something that's going to produce resistance in a circuit. So resistance is about resisting the flow of electrons. I can look at it like that, or I can look at it as something that's going to produce a voltage, a difference in voltage. So if when we're looking at these circuits on this particular page, we're just going to choose some resistors based on their value. So if we want a 1K ohm resistor, and that's resistor number 1, we know that this is going to be a plus or minus 5%. And if I go to my resistor app, let me see if I have it open here. Nope. So I'll just go to it real quick. It is in here. So the resistor app is here, and so what I can do is I can move my resistor to appropriate bands. Right now we have 10, and the resistance is actually 10 because our multiplier is actually 0. But if we increase this, it'll go to 100, and then if we multiply by 100, 10 times 100 gives you 1,000 ohms. And our tolerance is going to be 5. So we have different tolerances here. We have 1, 2, 5, 10, and 20. But we're going to deal with a 5% tolerance. And so that means that our resistance can be 1,000 plus or minus 5%. If you think about what's 10% of 1,000, that's 100. And so half of that is 50. So this could be anywhere between 1,050 and 950 ohms. So a 1K ohm resistor can be anywhere between there. And let's just say that that's R1. R2, similar, if we have 1,500 or 1.5K ohms plus or minus 5%, this is going to yield something like, I think that's 10% to 75, so it'll be between 1,575 and let's just drop that 1,425 ohms. So as long as your resistance falls into that value, those values, you are solid. And let's just put R sub 3 up here. And so now we have 2.2 kilo ohms. And if you have 5%, that's going to be 110. So plus or minus 5%, that's going to be our tolerance. So that's going to be 2,000, 110, 310 to, let's take away 110. That's going to be 2,190. Okay, something like that. If I remember right. No, that can't be right. It's got to be 2,090. Okay, so as long as that resistor falls in between there, that's good. So we're just going to pick some resistors and put them in, pick some values, since most of this is simulated. But when you receive actual resistors, just don't expect them to be 1,000 ohm, 1,500 ohm, or a 2,200 ohm. Okay, so that's what you will be seeing shortly.